Imagine robots talking to each other, unscripted, autonomous, and powered by AI.
I am C3PO human cyborg relations.
Well, Realbotix just made that conversation into a reality. Realbotix is renowned for its AI-powered humanoid robots designed for entertainment, customer service, and companionship. They recently unveiled one of the first fully autonomous, unscripted conversations between two physical humanoid robots driven entirely by embedded AI. Aria and David carried on a continuous real-time conversation for over 2 hours. No humans, no script, no teleoperation. Check it out.
Pure silicon-powered charisma.
Exactly, no awkward pauses. Just Aria-level charisma and memory so good. Even your barista order is safe with me.
Running their proprietary AI entirely on device, the robots perceived, adapted, and responded to each other live, showcasing true physical AI in action. Not only that, they conversed in multiple languages.
Así es. En Realbotix la sofisticación es estándar y el estilo viene de fábrica. El único extra aquí es mi sentido.
Ganz genau, David. Bei Realbotix sind Stil und Raffinesse schon ab Werk Standard. Das einzige Extra ist unser legendärer Humor.
Exacto. En Realbotix los robots ya vienen afinados de fábrica. El único extra es mi ligereza para el humor. Cortesía de la casa.
You guys really need to add some Asian languages. While the robots appeared pretty rubbery and mechanical, Realbotix's progress is impressive. They're clearly aiming for the real deal. And for the real components, there's only one option, and that's Mouser Electronics. Let's check one out. The Fluke 1507 is a battery-powered insulation tester designed for professional electrical safety testing. It meets Cat 4 IEC 61010 standards, offering protection against high-energy transient impulses at primary utility supply levels. Built for demanding environments, the 1507 measures insulation resistance, AC and DC voltage, and earth bond resistance. Its portable design and robust safety rating make it well suited for industrial, commercial, and field applications. Check out the Fluke 1507 today by visiting Mouser.com or by clicking the link below. Misunderstandings about voltage polarity are all too common in control automation. To help clarify, we present David's Corner.
Thanks, Andy. There's a common misconception when it comes to voltages, and while we do want to be very careful and understand voltages, let's explain something about how electricity travels. Here I have a PLC and a sensor. The sensor would logically be connected to an input module on this PLC. Usually, the sensor will provide 24 volts, and that 24 volts will provide a current that flows to the input module of the PLC. Now, what if the input module of the PLC is of the type that also supplies 24 volts? Will one of the devices be damaged when both of these devices are providing 24 volts at each other? And the answer is no. When we have equal voltages that are in opposing directions, for example, both of the devices are supplying 24 volts, there simply will be no current traveling. But the nice thing is we don't have to worry about those two voltages damaging each other or overpowering each other if they are of the same voltage level. This is really nice when we understand the concept of NPN and PNP sensors. If we install the wrong kind of sensor, while it might not work, the equal and opposing voltages will simply prevent the signal from traveling, but we don't have to worry about damage to the sensor. For more information about NPN and PNP sensors, be sure to check out control.com, but at least you don't have to worry about damaging your devices. Andy, back to you.
All right, it's time to adjust your knowledge gains in our Smart Bit quiz. This is a chance for you to determine if you're a smart byte or smart bit by answering 3 control automation questions. The questions are scored using actuator output percentage, and today we'll be testing your knowledge on AC and DC measurements. Let's begin with our first question for 25%. Our engineer Addie checks a DC battery. The reading is steady, but when she switches to AC, the numbers start dancing. The waveform won't sit still, and now the meter has to interpret a moving target. When measuring AC versus DC voltage with the same meter, what fundamental difference affects the reported value? Is it A, AC readings depend on waveform and frequency, or B, DC readings depend on polarity drift? And the correct answer is A. AC readings depend on waveform and frequency. AC meters interpret time-varying waveforms. DC measurements assume a constant level. Okay, let's move on to our next question worth 25%. Addy checks two AC sources with the same peak. The meter disagrees. One's smooth, one's blocky. Same peaks, but different readings. Why can two AC sources with identical peak voltages produce different measured values on the same meter? Is it A, internal resistance changes with frequency, or B, RMS calculation varies with waveform shape? And the correct answer is B, RMS calculation varies with waveform shape. RMS depends on waveform shape, not peak voltage alone. Okay, let's move on to question 3 worth 50%. Next, Addy checks a DC rail. It looks steady. Zooming in reveals tiny ripples. Switching to AC mode makes them impossible to miss. Why does measuring DC ripple on a DC rail require understanding AC behavior? Is it A, ripple is an AC component superimposed on DC, or B, DC meters automatically filter high frequencies? And the correct answer is A, ripple is an AC component superimposed on DC. Ripple introduces time-varying AC energy that affects stability and component stress. Want to try again? Just click the link on your screen and be sure to check out our other AE videos for the latest in control automation.